Do you think I should have the camera following me, like all the way, or should I have Sam stand here with the camera and watch me from here? One of us.
Well, are you...
Lovely babies. If I get swooped, we're putting it in the video.
Are you running back and forth more than once?
No, I'm going all the way along, so I'm doing it in order.
Right.
So you're placing our...
Pardon?
Are you placing our, like what we did on our guesses on the...
Yeah.
Okay, cool.
Yeah.
Why not do that and then we can kind of walk through it afterwards, maybe?
Maybe even if you just ran up to the end so we could see the end, and then we followed you through each step so we can hear you. Then we can see the whole distance and everything.
Yeah. Actually, Sam will have to follow me because otherwise you won't be able to hear me.
Yeah.
I was
And you
just
won't hear
thinking
my
that.
screams when the fucking plovers swoop me. Oh, there's
We're all here now, Ben.
Thanks. Oh no, there's a kid there.
Is this recording? Alright, you tell me when.
I'm recording.
Okay, guys, we are back. Sorry, I am not in shot at the moment. Basically, this is our sun, 2 meters in diameter. It's quite large. Think of a peppercorn on that. Alright, I'm going to get my cameraman to have me in shot. We're going to now lay down as the distances.
I think you have to be closer, Ben, just because you can't hear you very well.
Okay, so we're going to put mercury first, and we rate it as 2 centimeters, which, if we change that up proportionally, that'll be 2 meters, equal to 2 meters. All right, so here we go. 2 meters. So we've got 2 meters there.
That's the peppercorn.
So this is our one, right? This is it.
Yeah.
Yeah, this is our one. And
This is
next
it.
I'm going to do, the next one is Venus, again 2 meters away from that, 4 meters from top. There. Next, 3 centimeters further, for 3 meters.
You should record the screen with Ben's screen full screen, I reckon.
Alright, after Earth, so we go to 15 centimeters, so 15 meters, which is the middle point. So 15 is 7.5.
Smart to do it as well.
Mars is 2 meters away from Earth. I gotta go back.
I'm so glad I am not this role this week.
After Jupiter, we have Saturn, 6 meters away, which would be 1.5 less than that.
And this is our estimates.
Yeah.
Yeah.
Uranus, 5 meters from the end, 25 centimeters, 25. There is Uranus and Neptune over here at the very end. So I might just run you through it. So yeah, now we're gonna here's I'll borrow that. Does everyone see sort of like how far?
Yeah.
Yeah.
Okay. Next.
Kind of.
You can see a little white thing in the distance.
Yep, that's sun in the distance, all the way over there. That blue white sheet. How far away Neptune is from that?
How much do you know how much like each meter is worth in kilometers or like mile or 100 miles or something?
I know the distances of the planets, yes, and that I've got the facilitator info on that, but I won't share that just yet. Now what we're going to do, correct me if I'm wrong, do we now put them in the correct order?
Sure.
I can check quickly if you want.
I've got the thing here, it's just the other end of the centimeters.
So it says to talk about what we think now that we can see our prediction in 30 meters.
Yep. So what's the keep running?
I don't know. It's kind of hard to tell. It's hard to tell on such a big scale. I think the scale's too big.
Hard to tell
Where do you see it? Pardon?
hard to tell on computer screen, so that's one thing that there would be a very good activity in person, but it does have limitations on the computer screen.
Yeah.
That's something worth noting.
I feel like we can kind of see perspective though earlier when Ben was actually setting them up and we could see the size of Ben compared to the distance.
Yeah. Could you, how far away is Mercury to the sun on this scale? Where's Mercury on the scale? Can you put the camera next to him?
2 meters away from the sun.
If you start from the sun, so I'll get the camera from the sun. I'll get
Okay. That's Mercury.
Yep.
That's Venus. Earth. Mars. Jupiter. Saturn.
Yeah.
Uranus. Neptune.
Also, okay.
Wow.
That's so
That was helpful.
Thank you.
You wouldn't believe it, it's starting to rain.
Get it up then. All right, so I guess now we change. We go from Mercury first, and then we change it to the accurate distance, and then I explain what Mercury, the weather and day cycle of Mercury. Is that what we do now?
Yep.
All right, cool.
Right, so but we're going to put it to the group task. But first, I'll show you where Mercury actually is, and I'll put the pentagon down. So Mercury, we put it at 2 meters away. It's actually 38 centimeters. So
Wow.
Wow.
we would have put it at 0.28 centimeters. If we wanted to be correct.
Very cool. thought it was alright. 5 meter.
It was very close.
You were close.
So now, locations.
Yes. What do you think the weather's like on Mercury? Because of
What
how's that weather?
I think you take your sunscreen. Do we all agree, or do we think it might be cooler? Or
No, I think everyone would agree that it's closest to the sun, so it would be warmer,
Very hot.
drier, probably.
how long would a day be?
Well, Adam, you should tell us.
Yeah, sure. Do you want me to
Oh,
jump right in?
I've got the day lengths here.
Oh, you
I
do?
can tell you how many hours a day is, but how long do you think it is? Because, all right, let's think about it. So it's right next. It's so close to the sun, and the sun's so big. It's got to travel around the sun. If something's further away, sorry, no, that's a year. Oh man, I'm so
Yes.
stupid. So the day is the rotation of the planet, isn't it?
Yeah. It's hard to know. It's hard to estimate what that would be.
Yeah. How fast is it gonna spin? Does anyone have an idea? Other
I
than
think it would be, having a guess, I think it would be the shortest period of time being closest
smaller,
to
right?
And
yeah,
it's smaller, yeah.
But that would mean, but it's based on how fast or slow it's spinning too, isn't it? Do they
So,
kind of spin at different rates?
so what's the estimation you guys? What hypothesis do you want to say? Do you want to say the smaller it is, it's faster it spins, or the smaller it is, slower it spins? What do you guys think?
I know the answer.
Or would it be though?
Because the faster it spins, the quicker the day is.
At this point, we're sort of just, we just kind of got to put it till we don't know.
Yeah.
I feel like we're guessing it. I'll tell you, it's 1,408 hours is the day length of Mercury. So I guess the implication there is that it spins much slower.
Okay.
Do we agree?
Yeah, because it's so small.
I don't know if that. Well, I don't know what affects the speed.
Yeah.
You know what? As we go through this, I think we're going to see that.
Yeah. Okay. Well, I'll explain a little bit about Mercury. Because it's so close to the sun, it has extreme temperatures. During the daytime, the sun would appear 3 times larger and more than 10 times brighter than it does here on Earth. All of the sunlight can push temperatures as high as 427 degrees. Then at night, because there's no atmosphere, because the planet's so small, the daytime heat doesn't get trapped, so the temperatures can get dropped as low as 184 minus 184 degrees.
Extreme. Nice. Thank you, Adam.
Okay.
Venus, we said was the same distance, so 2 centimeters, 2 meters away. It's actually 72 centimeters from the sun.
Oh. Yeah, we all did a pretty big jump from Mercury. That's surprising.
That's why I was starting to think, oh, I don't know. You might be right because, yeah, like I wasn't actually thinking like it is like hundreds and hundreds of miles still in between even these half centimeters.
Yeah, when it's on a piece of paper, you think, oh, that's a bit close. But even then, even looking at Ben's proportion there, it looks pretty small. Pretty
Yeah.
close to the sun.
So, yeah, what do we think the weather's like on Venus?
How about that weather?
Too? Look, I'm going to say it. I think it's still going to be hot.
I think it'd be pretty hot.
The day length. Does anyone have an idea of what the day length might be based on Mercury? So we know that Mercury being 1,408 hours.
Well, it'd be roughly the same length. It would be like around 24 hours, wouldn't it? Because it's roughly the same size as Earth.
So we're going based on the size, yeah.
That's what I would have done before knowing the CDSU. But yeah, I would have
You
said
don't tell us that.
I think it's the same because of the size of Earth, which is totally reasonable. And I would have gone more with the distance from the sun, so I would have said it's longer than Earth, just because Mercury is closer. But anyway, the actual hours is 5,832 hours per day in Venus. So I guess it's proportional to how slowly it spins.
Yep.
Anything to add? CDSU?
Venus. Well, if you want the CDSU now,
On Venus?
yeah,
Yeah, I think we're ready for that.
far away. Okay, well, you'd think that Mercury would be the hottest record for the planet because it's so close to the sun, but Venus is actually the hottest because it's covered by a thick atmosphere of carbon dioxide and clouds made of sulfuric acid. It acts like a greenhouse, trapping the heat and warming the planet. Venus can reach a scorching hot average temperature of 453 degrees. If Venus ever had oceans, they dried up a long time ago.
Do you think it could also be like partly because of how slow it spins, like it has such a directed amount of heat on one spot for so long?
Yeah, it could be.
Yeah, I don't know. This heat's significant enough. But anyway.
It really is to do with trapping that heat at night, though, because
Yeah.
it doesn't have that trap at night. The heat just runs away.
Yeah. Yeah, I guess if it was just on one spot, it would just be hot spots rather than a hot planet.
Yeah, it's just an oven.
Alright, so Earth, we're moving, Earth is 1 meter away.
You got 12 minutes, by the way.
12 minutes.
How long is well, we know what the weather is like on Earth, right? I'm sure we still have to
Yeah.
sort this. It's really close though, like everything's really close to each other. I don't think it's like 24 hours in a day for Earth?
24.
Yep.
Yep.
You guys want to know, what do you guys think the average temperature is of the Earth?
Well, that's a kind of a tricky thing, isn't it? Because there's the Arctic and the Antarctica and everything, and then there's tropics.
Yeah. It is tricky. You reckon you could put a degree on it?
Yeah, 20
20
something.
It's 14 degrees. And the highest that it's ever reached in a desert is 70.7 degrees, which was taken at the lush desert of Iran. away from Iran, I guess. The deserts of Iran.
That's interesting. So the average degree of the Earth is actually half of like Australia's summer. It's like the average Australian summer. It's half of that.
That's nice temperatures.
That's true.
All right, I'm going to move on to
Mars.
So Mars is 1 meter 52 from the
Yeah, we really did.
Wow.
Did it a little bit off, didn't we? Even, yeah. It's like not even within 2 centimeters yet.
No. And it's already like the fourth planet.
Yeah, it's crazy.
There are
Moving
terrestrial
way off.
planets, right? What do we think the weather is like on them?
What do you reckon, guys?
I want to say similar to Earth. Anyone else?
No.
And how long do we think day length is on Mars?
Well, I don't know. This is kind of it's. Hang on. How long? Wait, was it said how long the day length was on Mercury?
Oh, sorry, did I not say that? The Mercury day length is 1,408 hours.
So Jupiter, well, going off that, then everything's getting shorter and shorter amount of hours, right? So
Potentially draw that from Venus was 5,832 hours.
hang on, what was Mercury again?
1,408.
Oh, okay, never mind.
Then Earth was 24.
Yeah.
So there's sort of like a trend.
I don't know. I'm gonna take a guess at 200 hours.
It's kind of hard to put numbers on it because there's no pattern that we can see yet.
No.
You can't really see the pattern yet, can you?
Yeah.
It's a bit different.
So the hours for Mars is 25 hours. The day length.
I find that pretty interesting. Almost the same as Earth. And it's such a different size as well, and distance.
Any CDSU on Mars?
Yeah, do you guys guess what the temperatures are on Mars? What do you reckon? Do you reckon it's a cold planet or a hot planet?
Colder, maybe.
Yeah, I think it'd be colder.
Yeah, from what I know, it's closest to being livable for humans.
I always thought it was a hot planet. I don't know why.
Because it's
And then
red.
I read up on it. Red, I guess, but
Yeah.
it looks like but no.
Honestly, I think without looking at the order of the planets, I would have said it was a hot planet just because it's red. Yeah. But then now I'm seeing it's past Earth. I'm like, oh.
Yeah. Yeah, well, the higher range of the temperature.
15 centimeters and 15 meters. This one is actually 5.2 meters.
What's this?
What's
Mars.
that one?
Jupiter. Well, Mars.
Jupiter.
Before we go on to Jupiter, Mars is
Keep talking, yeah.
yeah, Mars is the temperatures go to 0 degrees. That's the higher range of them, and they drop to 53. Sorry, I know temperatures can be more like 53 degrees on Mars, and they drop to, I've got Fahrenheit here, but 143 Fahrenheit.
Which I think is
Oh, right. That's right. 50 degrees Fahrenheit.
Sorry, 61 degrees. Minus 97 degrees for Mars.
Wow, minus 97.
Yeah, that's the lowest, and the highest is like 0 degrees
Okay.
on an average day.
So
Yeah.
it's cold.
Yeah, it's
So
pretty cold.
how far was Jupiter again?
5.2 meters.
I think we did 5.6 meters. Was that what you said, Ben?
5.2, sorry.
5.2.
We said it was 15 meters away.
A little bit off.
Jupiter feels. What kind of weather do we think? I'm gonna say cooler.
Yeah.
It has to be cool, right?
I think so.
Isn't it? Wasn't Jupiter the one that they thought might have water on it that's all frozen underneath the surface? Or
Yeah,
was that?
because it's a solid planet too, I think.
Mm.
That's what Nathan said earlier, wasn't it? That there was ice.
Mm.
Yeah, on the furthest pole.
Cooler. Probably. Do we know what a day length might be?
I'm still not seeing the pattern yet. I should have right.
Yeah.
Why don't we do you think it's a shorter day length than Earth or a much longer day length?
Yeah, that's what I was thinking. Maybe instead of trying to think of numbers.
Mm.
I reckon longer.
You reckon it's a longer day? Who else?
Ready? It's
Yeah.
short. So this one's 10 hours.
10
10
hours.
hours. Wow.
10 hours.
Yeah, very slow.
Very slow moving. Yeah, can we?
I think it would have a long surface area to cover as well.
Mm.
It would have to move very, very fast for it to be a quick day because how big it is.
So 10 hours means it's flying.
Yeah.
Spinning.
Yeah, true. True, it's quick.
Interesting to see. It would have been an interesting piece of information. Again, I think, like, you know, if we were doing it again to how far, like a kilometers wise, it spins, or how many miles per hour it spins.
Mm.
Yeah,
That could have been interesting. Because then we'd see if it was all based on the size, like if it was partly based on the size of the planets, or if it was how fast it spun as well.
Jupiter spins at 13 kilometers per second.
Per second.
Do you know
Yeah.
how fast Earth spins?
Yeah.
1,670 kilometers per hour.
Mm.
Yeah, interesting.
Should we do
That's a lot.
Saturn now?
Wait,
That's an incredible amount less.
yeah.
Because, like I said before, the size of Jupiter is so big, it needs to travel so fast for it to get a 10-hour day.
Yep.
That's right.
142,800 kilometers in diameter. Jupiter.
What's next?
So the weather on Jupiter is minus. The temperature in the clouds of Jupiter is minus 145 degrees, and near the center of Jupiter is much hotter because there's no surface. It's clouds in the center of Jupiter. It's the core is 24,000 degrees.
Wow.
Hotter surface of the sun.
Wait, sorry, what was that? 24,000.
Yeah, which is hotter than the surface of the sun. It's
Wow.
interesting.
Hotter than the sun.
And that's
Just the center of Jupiter is hotter than the surface of the sun.
Wow.
It's pretty interesting.
Hmm.
And yeah, because it's a gas giant, can't really spend much time on it. Wouldn't really know what the weather's actually like, but it's a stormy planet. If you do you remember seeing a picture of Jupiter and you have those red dots on it?
Hmm.
They're actually like giant wild storms that have been raging for like 300 years. Yeah, and the atmosphere is most likely made of ammonia, which is a compound of nitrogen and hydrogen.
Interesting.
Yeah, there you go. I'm learning a bit.
You have to go, Nathan.
Yeah, Adam, I can send you some key points, or I can just add my CDSU. I'll record myself, and we'll just add it to the end of this clip. If that
Yeah,
works.
that'll work. Get your input in. Yeah, sure.
I'll just send you the main points I have. I'll also send you guys some information I have, but I will explain this to everyone, and I'll record it, and then I'll just add it to the end of this.
I won't go
So
through
we
it.
can look at it at the end.
Sounds good.
Is that all right with everyone? I
That'll
can do
work.
that. I can do that even.
I
Yeah, I finished tonight, so I can just do that tonight, and we'll get that through.
Awesome.
Sounds
Okay,
good.
I'll watch the rest of this experiment too when I'm back from work. Sorry to rush, guys.
All good.
Okay.
I'll talk to you
Sorry,
soon.
so long.
Okay, bye.
Hi.
Alright, so
So next one is, are we all right?
Mm-hmm.
Next one is Saturn, and it is 9.8 meters RHS. Meters.
9.8.
9.58.
9.58.
So,
Hey, that was. Oh, wait, no.
2 meters and 8 centimeters for.
I had just random numbers placed in my graph as an example of what the graph could look like, and I was like, whoa, 9 is exactly on point. But it wasn't. It was just a random number placeholder. I got really excited for it. Well, we got 1.
No, we're a little off.
Just a-
I thought they were a bit more of an average distance, but I guess not.
I thought the last 4 would be pretty spread out, but they actually happened.
We got that reasonably away. So, what do we think the weather is like on this one? Because I'm going to say
About that weather.
Mm.
Colder than Jupiter. Also, just so you guys have a reference for the size, it's pretty close to the same size as Jupiter. It's like 110,000 kilometers in diameter. Saturn. Except, yeah, I don't think the grapefruit and the watermelon represent that so well.
Oh, okay.
2,800 kilometers in diameter. So they're actually much closer than the grapefruit. It's, I think, maybe.
In the melon.
Yeah, like maybe it's like 50 or something.
Yeah. What do you guys think? What's the weather like?
I think colder. Colder than
Cold.
Cold.
Mm.
Okay. What about a day? Do you reckon slower or faster than Jupiter? Not hot and
Faster.
faster? So a shorter day?
Yep.
Okay. The day for that is 11 hours.
Wow.
So they're pretty close.
Yeah, very close.
Mhm.
Yeah, it's kind of surprising how close like you have Mars and Earth, and then Saturn and Jupiter that are too close. The temperatures, because it's so far away from the sun, it's like 900 million miles away from the sun, which is almost twice. Says no, well, I guess not. But the distance comes to a freezing average temperature about minus 176 degrees. Most of the weather. Well, then it goes on about the moon. They think that the moon of Titan has seasons and clouds and rain, and has an atmosphere largely of nitrogen, just like ours. Unfortunately, rather than a weather cycle, Titan channels a chemical called methane, and the rain from the clouds of methane falls into the lakes, rivers, and seas. So you can't really habitat that moon, but it's got weather. It's cool.
How long it will take to get here. All right, do we want to move on to Uranus?
Yep.
Uranus was 19.2 meters away
Mhm.
from our sun, and we put it at 25. So kind of close, ish. Anyway, I'm going to measure from the middle one. The middle one's 15 meters, so I'm going to measure 4.2 meters from there.
Got your cardio in for the day.
All right. Yeah, shiny ones. What do we think the weather's like on Uranus?
How about that weather?
Yeah. I imagine snowstorm almost. Like they'll have to have some kind of storms, right? So like maybe snowstorms.
Blizzards. All right. Yeah. Do they have to have storms?
No, but you'd assume. I don't know. I'm just fully. I don't even have anything to back this up. I'm just assuming.
That's all right. No, but I do think it will be colder, still colder than Saturn.
Yeah.
Do we have yeah? Do we have an idea of hours in the day? Relative, say, to Saturn, which was 11 hours, and Jupiter was 10.
Maybe 15 hours?
Maybe 8. Maybe the whole other direction.
And why do you think 15, Sarah?
I don't know, maybe because it goes pretty fast and it stays really cold. I'd have no idea.
Oh, okay, no, that's all right.
Yeah.
And Victoria said 8, right?
Yeah. I think it's mostly most of them are going down in hours. So I think it has to be less than 11. But at the same time, every time I thought it could still have some and then the only two that were a bit out of it were Mars and Jupiter because they went up. Oh no, sorry, just Jupiter. Jupiter went Mars. I mean, Mars went up.
And Venus.
So I was thinking maybe it was just this a size plays in a factor as well. But because this is continually getting smaller now than Jupiter, I think it will go out. I don't know. No idea.
out your misery, and you won't be happy, Victoria. It's 17 hours.
Man. You know, just put a 1 in front of it, and I was close.
Adam, you want to give us the CBS please?
Yeah, sure. Uranus is known as an ice giant. It lives up to its name. Its temperatures are about minus 217 degrees. It's tilted on an axis of 98 degrees, which scientists believe that it's knocked on its side by a large object a long time ago. And this tilt affects the seasons dramatically, and there's very unusual seasons. In summer and winter, large parts of the planet see nothing but daytime or nighttime for the whole season. The
Wow.
21. In spring, fall, Uranus goes through a full day to night cycle every 17 hours. Sometimes it has huge storms, and this unusual seasonal cycle might play a part in them. Yeah, it's interesting that the axis is so off compared to the other planets. Changes at all. And since it's so far away, it takes about 84 Earth years to make a single orbit.
Wow.
And each of its seasons is 21 Earth years long. Yeah, that's it.
Moving on to the last one. Neptune. It's over here.
Cool.
I mean, if you look down the end, you can't even. You can see the sun. Yeah, like that watermelon is looking so small. I don't know if you can see it. But it's pretty cactus. I'll do a walkthrough right after this, but yeah, what do we think the temperature's like on this on Neptune? It's 30.1 minutes away, by the way. Didn't need that.
Would you say 30.1? Yeah.
And it's
It'd be freezing.
I'm gonna say ice.
Ice cold.
This is the blue planet. Is Neptune blue?
Yeah,
Yeah, I think so.
it is.
What? Or is Uranus? I don't know. Maybe I'm just doing something wrong.
Neptune's the blue planet.
Yeah, so I'm gonna say it's like icy cold.
Well, as Uranus, actually, it's light blue, but Neptune's dark blue.
What else do others think?
Yeah, what do you guys think?
Does anyone think it's gonna get hotter?
No, I think it's gonna be colder.
Yeah, I think it's just going to continually get colder.
I don't know what the hours would be though.
Would they be longer?
Does anyone
I have absolutely no clue.
No.
Maybe I'm just gonna say 20 hours. Mm.
Alright, so the hours length is 16 hours for a day. So roughly like
The weather, this is also, sorry, what was that?
yeah, do you want to do the CDSU?
Do this here? Okay. This one is 2.8 billion miles from the sun. That means this ice giant is very cold. The average temperature on Neptune is about minus 218 degrees. It's familiar because it might sound familiar because it's pretty close to Uranus. It has about the same temperature. The other one was like Neptune. Uranus was like minus 217 degrees, I think.
No.
The reason why the planets are the same temperature with such different distances is unknown.
Oh, so even the scientists don't know why.
Yeah, they don't know why.
Wow.
Neptune has a thick atmosphere and is covered by constantly changing clouds that whip around the planet. Wind is the name of the game on Neptune. Wind speeds that have been measured to near 1,200 miles per hour, making them the fastest in the solar system. Yeah,
Wow.
I win. That might. No,
Wow.
Does
Amazing.
has anyone figured out a pattern yet for the hours and that? Or even
No.
no? I'll tell you what throws me is Venus Earth.
yeah, it throws me off a bit too.
They're about the same size, both planets, but just
Yeah.
the difference in hours. 5,832 for Venus and 24 for Earth.
I think there's two factors from what I gather. I think the two factors are that closest to the sun has that strong gravitational pull and has a lot to do with the size as well.
And
But I don't.
Yeah.
it could also be like what the planet is made of.
Yeah, that's a good
The
point.
actual composition of it.
It's a very good point. Like it does have a lot to do with the weight of the planet. Like a gas planet doesn't have that much weight, so it might affect that.
Mm.
Yeah, that's good. Guys, so now I have to, we've done that, take you through just a silent walkthrough of our line of the planets, and basically take get a sense of how big or small the sun would be from the perspective of each planet. Do you think I should start probably from Neptune and walk towards the sun? Might be an easier one to do instead of
Yep.
going backwards.
Yep.
I'm going to go off screen to do this. And yeah, so I'm starting at Neptune, and there's the sun.
Wow, that's a huge gap.
Yeah.
And even there.
Cool.
So yeah, do we see any patterns? Like, what are we noticing? I mean, we know that the terrestrial planets, they just look bunched up here, right next to the sun, and obviously we understood from Adam's explanations that they just get colder and colder as they go further out. But what else did anyone get from? Or did we get more from this? Or? So these are our observations, basically. There's probably more for
I
you guys to
reckon
see.
the 4 planets on the end, so they're like pretty much freezing cold in their minus degrees. I think it's because it's got heaps of room between them. So that's the pattern that I'm seeing. So the more space between them, the colder they are. And then the less space between them, the warmer they are. obviously, like towards the sun, if that makes sense.
Yeah,
Yeah.
but yeah, distance from the sun or distance from each other?
Both distance from the sun and distance from each other.
I'm really interested to hear when we like just the one. I think it's interesting that the days, the hours in a day just change so much.
Mm.
Yeah,
Like
well,
it's crazy.
I think that's something we need to, I guess, gonna have to come back to and hopefully get the CDS.
I think that's what Nathan's covering, isn't it?
Okay.
Yeah, so he'll
So,
have a recording and then we can watch that.
yeah. And obviously, I just want to go over it quickly, but we've done the health and safety and that. We did the
Diversity.
curriculum. For diversity for this one, I suppose it's quite open, isn't it? Because the only thing, even with, say, visually impaired, they could pace out different things, like help assisted that way. EALD, it's sort of no problem because it's visual. They can see it, and they understand the different planets and representations. It's all sort of the same stuff for diversity and that. That's that. An assessment for this activity. How would we get this one? Because I don't think you'd get every student to map out 30 meters. I feel like this is
I think as a class, you would you might do the 30-meter one, but I actually think that the 30-centimeter one was just fine. Like you still got to see what it would be like, and then you can also, if you figure out the diameter, which it might just be a pinprick, but if you had the same like sizing and diameter wise, you'd be able to see how small the planet was in comparison to the whole expanse in between.
Yeah, no, that sounds good. I'm quite happy with that. Is everyone on the same page now? We all feel confident? I totally forgot. We have to talk about the left-hand side, don't we?
Yeah, well, I've got to tell you about my data on this one first. So, oh no, it's all good. So I'll share just that one thing. I won't share my whole screen, just that page. I've just been putting in the stuff for it. Where is it? So this is basically, zoom out. This is called a bubble. Is it a bubble scatter plot? And yeah, you have all your information, and then you can change the size of the circles and the amount of circles, everything to do with that. So along here we have the distance from the sun. So it's not actually a cross that's the distance. It's probably better that way. I'll see if I can change it. But this is the distance from the sun, and then this is just each planet along here. So then it gives you a pretty cool idea of how far away each thing is from the sun. Like look at this tiny little planet over here. I can't. The only problem with this is that each planet it's not the correct sizing in comparison to the amount of distance in between. But I think if you were to do them, you wouldn't see the planets. It would be too minuscule on this tiny little scale.
Right. How come we can't? How come Neptune isn't on 30 centimeters?
I don't know, actually.
It's 30. It was 30.1 on the facilitated document, and I did say perhaps that's the reason.
Well, I have it written here as 30.1. There's something just went wrong when it was putting it in. So I'll just make sure that's all fixed. You can still see the idea behind
Other than that, I really like it. Good
I
data.
thought it's a more the type of graph. It's more it's a more visually understandable data for younger kids to be able to see and then
Yeah.
see the representation.
Cool. That'll work nicely. So you'll make that up.
Yeah.
Zara's got the first activities graph.
Mhm.
Right. Left-hand side.
Yes.
Yeah, I think we stated our observations before after the little walkthrough at the end. What do we think? How are we going to represent our science learning has been like, it's hard to
Well,
learn so much. There's so much to it.
I feel like
How
it
do
is.
we wrap
I,
it up in a nice bow?
because we, like, everyone's done posters and everything, like, for the few weeks so far. But I remember when we did the first technology course we had, for one of those assignments, I used an interactive poster where you have, like, your background picture that you set up, but then you can set up little, like, things that you click on, and it comes, and you can, like, create your information within that.
Yeah, I think that sounds like
That's really cool.
that's kind of almost what they had in that first the week 3, the first performance in the week 3 one, the first left-hand side done in the week 3 one. They it was an interesting style because that means if we were able to set it out, we could try and measure, the distance between each one and we get an accurate ish.
We could just use a photo of the solar system.
Yeah, that's true.
Yeah. And then we could put up little sections for, like, the pedagogy or whatever else we wanted to put in there. Yeah.
Yeah, like when you click on each planet, it comes up with all the information about that planet.
Yeah. Yeah. And we didn't even talk about the distance and that. Yeah.
We can,
Yeah.
if we can get that to work, that's a really cool way to do it. And you also get that bonus of the actual representation of how far
To
away things
see
can
it.
be.
Yeah.
And what about, and then even as a teaching thing and pedagogical learning, this whole thing has been about visual representations. You know what I mean?
Yeah.
So,
And getting that perception. Yeah.
Yeah, so this whole thing's just been on visual representations. So it kind of makes sense to do that again, doesn't it?
Yeah.
Present this visual.
Yeah. And it has to be done in a child-friendly way, which is all visual.
Yeah, and the interactives in this as well, because that was the whole point of this, was being interactive for students. Mapping out the 30 meters wasn't just to get computer, it was to get students to feel like almost,
Like they're a
feel
part
how
of it.
long they can be.
Make them remember it a bit more too. They can see that big proportion.
Oh, yeah. It was so
Yeah.
engaging. Yeah.
Yeah, I really liked it. Good activity. I think it was the best one so far.
That'd be cool. So you reckon we can do it? Does anyone know how to make that?
Yeah, I've done it in an assignment.
Is Sarah still here? Did we lose her?
She said her mum needed her for a minute. So she's
Fair enough.
here but not here.
Yep, got it. No problem. I like that. So basically, when we hover over or click on a planet, say Earth, drop down, is that what will happen? Like a drop down information?
Yeah.
I think we
So
could.
length of day.
Yeah, we could put
Basically,
little writing. We could put like an arrow, a little writing or something in between the planets as well to show how many miles or whatever in between each planet.
Yeah, and I can even do it, and maybe we could send it on like a Google Doc or something so everyone can see what we're kind of talking about. Because it might be a bit hard to kind of picture in your head.
Yeah.
Yeah.
Okay, yep. Look, I'm really liking the sound of that.
Yeah, I think it's a cool,
Right.
cool idea.
So all this will be due on the Thursday.
Thursday.
Yeah, at 5. So, Katie, you're just You're that person, the submission person.
Yep.
Alright, I'll send you a thing. I'll send you all my World 2 stuff beforehand.
Yep.
Done.
Cool.
Awesome. That's everything.
Yeah, I think
Yeah.
we're done.
Okay. Don't know what happened to
Cool.
stuff. That's cool.
Yeah.
I might stop recording now.
Yeah.